imagine this is the vertical plane. Yes, you may put your attendance in the chat box. So imagine this is the vertical plane, and so this one is your vertical plane. This one is your horizontal plane, and the one that we are left with is a profile plane. And for this time being, let's consider that uh, we are only performing first angle projections, which basically means the screen itself is further to us than the object. So now, okay, now imagine you have this point A that you want to project. Okay, so why we are starting with a point that if we can project a point, and then we can project more than one points, so therefore mm, we can also project a line, and then we can build up on from line to surface and then surface to volumes. So in the end, our goal is to, of course, project three-dimensional objects, but let's start with points. So again, please understand that we are doing orthographic projections. So what I'm doing now is dropping a perpendicular on the vertical plane. And let's say I'll call it, let me double this point as small a. So I'm calling it A prime. And then I can also project it on the horizontal plane, and it would be A double prime. And at this point, everything might seem to you is quite obvious, which I agree, which it should be actually. And then uh, the way we did earlier, we would look into the vertical plane, and and its height. Okay, we would know from the projection. So let's say that is A prime. Okay, and what we would do, we would have the horizontal plane, and as we discussed earlier, after taking the position, we'll rotate it counterclockwise, or rather, in this case, it looks like clockwise. So we rotate it clockwise. So what we have here is our horizontal plane, and there's a line that separates between the two planes, and on that plane, we'll have the projection of our point A double prime. Okay. Now, in the similar way, we can project this point on the profile plane A triple prime, and we can actually take the projection on the profile plane and then rotate the profile plane in the direction shown. And after taking the projection, we can also align the profile plane with the vertical plane in order to have the side view. Okay. Now, so the profile plane after opening will sit next to the vertical plane. Okay, and so so in that, on that plane, the projection should be A triple prime. And I'm not showing that A triple prime point on the profile plane, because what I'm about to show is a set of construction lines. So basically, I would draw a line which is parallel to x-axis. Sorry, not x-axis, the line xy, which would act from the A prime point, that would actually give you the ordinate. If you think of this one as the x-axis and this one as the y-axis, so basically this distance, let's call it h, so or h1 maybe, that is the distance from the horizontal plane. Okay, so anytime you are drawing a point on a given plane, you are basically using the coordinates uh, which essentially represent distance from any given plane. For example, let's talk about the Cartesian axis and the Cartesian planes of ours. If you are on xy plane, and which is basically normal to z axis. Now if you have a plane whose coordinate is x and y, sorry, if you have a point whose coordinate is x and y, now the actual point of ours is a three-dimensional point, but any of its projections are is one such uh, 2D or planar points. Okay, so what does the x coordinate represent? So this one is this distance is the x coordinate, and that actually represents the distance from yz axis. And if you talk about the y coordinate, that essentially represents the distance from xz axis. Okay, so if I draw a line parallel and bring it to the projection plane, so on the projection plane, what I'm bringing in is a distance from the horizontal axis. Okay, because on a vertical, this projection on the vertical plane, okay, this distance right here is it. Let's say h1. This actually tells you what is the distance of the point A from the, not just the projection, but also this point A from the horizontal plane. Similarly, this distance h2 represents the distance from the vertical plane. Now, this distance is h2. Okay. Now, in this plane, in the profile plane, okay, this point A prime, you can think of like its coordinates is h1, h2, where h1 is the distance from the horizontal plane and h2 is the distance from the vertical plane. Okay, uh, so that way, uh, all I'm trying to say here is the three projections, they are not mutually independent. Okay, you'll have to understand that this point over here, this point A over here has three coordinates x, y, z, which are independent of one another. But once you take two projections, okay, once you take two projections, so that basically in a given plane, the coordinate of the projection is given by two values. Okay, again, if you take two projections in two different planes, so basically you have four values representing the position of the projections, or representing the position of the point. Of these four values, three are independent. Okay, so all I'm trying to say here is once you have two data points, okay, uh, see, I'll tell you um, which coordinate is not independent. The distance from the profile plane, let's call it h3, that is going to be same in both vertical and horizontal plane. But the remaining set of values h1 and h2, they are independent of one another, and those are the only two values that you need, only two values that you need to plot the point on the profile plane. So once you are given the mm, distance, I mean distance from the horizontal plane, which is h1, and distance from vertical plane, which is h2, you should be in a position to draw that point on the profile plane itself. So at first you can start with the position on the vertical plane and the position on the horizontal plane, which is this one, and then you can project that point back to the profile plane, and that is what we are learning right now. So once you move on to the profile plane, the distance from horizontal plane, okay, h1, that is going to remain the same. Also, the distance from vertical plane h2, the distance from vertical plane of the point a double prime and the a triple prime are the same, which is h2. Now, how do you take h2 to the profile plane? For that, there are two ways to do it. Uh, One is that you draw a line, okay? Um, you can draw a line which is which is making an angle of 45 degree, okay, with any of the two lines representing the horizontal or the profile of the horizontal plane. And then from a double prime, actually you can draw a horizontal line, okay, or line along x-axis, okay, which would intersect this 45-degree line somewhere, okay. And then you can drop a perpendicular from this point to this line, and in turn to okay. Is there some mistake? No, I guess. We need to ensure that so h2 is the distance from vertical plane, which basically means we need to ensure that this length and this length are same, which would be obvious if this angle is 45 degree. So yeah, yes. So that way you get the point of intersection, which would be a triple prime. The other way to do that would be to instead draw. So let this horizontal line intersect with the border of your uh, horizontal plane. So let it intersect with the border of your horizontal plane, and taking this the intersection of the three planes as a center. Okay, you can call this point as O. So take O as a center and draw a quarter circle, which would ensure that this length is same as this length. And then from over here, draw a vertical line. Okay, and wherever that vertical line intersects the horizontal line coming from A prime, that point would be your A3. So the idea is the same. You need to keep the same distance from the vertical plane, which is H2. Okay, এই পার্টটা কি বোঝা গেছে? কারো কি ডাউট আছে? তাহলে একটু বলো। মনে হচ্ছে সবার ক্লিয়ার হয়নি।
স্যার আরেকবার
হ্যাঁ,
বললে
মানে
ভালো
স্যার
হতো।
এতগুলো স্টেপ দেখার পর একটু কনফিউজ হয়ে গেছি।
আচ্ছা, so for that, what we can do is, let's start with the simplest problem that we can find. Okay, and that would actually help us in understanding the steps. Okay. আচ্ছা, একটা জিনিস বলে দিই, এখানে যে আমরা ড্র করছি, আমি একটা সফটওয়্যারে ড্র করছি, which is not very efficient, and it is drawing this rectangles. So whenever it detects I'm trying to draw a rectangle, it does so automatically, and then it makes thick lines. Okay, so but all of this is for illustration. Okay, uh, your actual drawing would be somewhat like this. Okay, if you are only drawing points, so you need this line that separates between the horizontal and the vertical plane, xy. Okay, and in that actually you can have a line which separates between your vertical plane and the horizontal your profile plane. Okay, but to start with, maybe you only represent this one as vp and this one as hp. Okay, so your page looks kind of like this. and what would be given to you. For example, I'm looking into the book by Pal Bhattacharya, and in that I'm going for 6.1 from the exercise 6.1, and problem number A, which says, so basically it is asking you to draw projections, basically all the three projections of points. So in the first example, okay, basically okay, so A is draw point A, okay, which is 20 millimeter above H, and 25 millimeter in front V. Okay, so what is it saying? This is a vertical plane, or V. Actually, you can simply call it V, and this one is H. So it is 20 millimeter above H. So if this is the point A, so that is 20 millimeters above its projection A prime right here, or A double prime right here. And then on the vertical plane, it is in front of the vertical plane. That means you are looking at it from here, and it is in front of the vertical plane by how much? 25 millimeter. Okay, so these are the only two values that we need. Okay, so given that, we can start anywhere. Okay, ideally this xy line should have been infinite. Okay, so there is no guideline on that. Now this one is A is 20 millimeter above H. Okay, so on the vertical plane, it looks 20 millimeters above. Okay, so basically I would take a point A, or I can call it A prime. You don't have to draw this line in the form of a hidden line. Ideally, what should you should be doing is, see, any line that you draw, or that should be thin line at this point. Okay, because you are not actually dealing with lines to represent the edge. Okay, so any line could be thin line, and anything that you use to construct or to represent the barrier between two orthogonal planes, all of those lines are thin lines. Okay, only when you start drawing the solid boundary that you have, then you'll have to draw thick lines. Okay, so now what I'm about to draw is a so-called construction line. That means I need this line to construct the projection. So all I'm trying to represent here, that these two lines should be vertically on, along these 2 points should be on the same vertical line. That's the point I'm trying to make here. And so you have been given that this H1 of yours is 20, and this H2 of yours is 25 millimeter. Okay, so about somewhere over here, that you have your A prime, A double prime rather. Okay, and let's say now you may be interested in finding out the profile view. So what you can do is, so imagine this line separates between the profile view and or profile plane and the vertical plane, and I'm extending the xy line actually. Now again, I'm drawing a set of construction lines. All of these lines are thin lines, by the way. Okay. Now this height is basically represents the distance from vertical plane h1. And once you take the projection on the profile plane, let's call it p. So for this a triple prime right here, that distance is going to be the same. Oh, sorry, this one is possibly 20. Okay, you can put a dimension. So there are two ways to dimension something. One is the align mode, the other one is unidirectional. So we would be going by the align mode, okay, which basically means this dimension, vertical dimension, should be read from the right. Okay, that means someone from this side is looking at it. Imagine your eyes are over here, okay, and you are looking at it like this. So this is how you write it, okay. And since the dimension is in millimeter, we don't put any labeling of sort. You don't need to mention that unit, okay. So acha, now for the a prime, a double prime, um, and show the dimension. And this is how your arrow edge should be in a dimension line. um, so it should be completely black. Also, the edges should be straight line, these edges. Also, this thickest portion, if there is W, and this one right here, if this is B, then B is to W is 3 is to 1. Okay, it would take practice. In the beginning, some of you would be doing something like this. And some of you would not care much and would probably do this. All of this are incorrect. Okay. Anyways, I'm kind of not able to do that because I'm drawing on a computer screen. So this is how it should be. Now this distance from the horizontal plane, that remains the same on the profile plane, or you can call it PP. And for the distance from the vertical axis, that is by how much it is in front of the vertical plane. So you need to draw this line right here, okay. And there are two ways we discussed. One was to draw a line which makes an angle 45 degree with any of the horizontal or the vertical lines. So that way, when you extend this line, this length is same as this length, okay, because this angle is 45 degree. This angle, of course, is 90 degree. So it is actually um, mm, your isosceles right angle triangle. Now, on this side also, when I extend this line or drop a perpendicular over here, this length is same as this length. And you see, all the four corner angles are 90 degrees. So this is a rectangle, and rectangle with all of its sides equal. Okay, so basically we know that this length is same as this length. Okay, and why we need that? So basically, what is this distance? This distance is actually the So this distance is h1, the distance from horizontal axis. Okay, and this distance is h2, the distance from vertical plane. Sorry, the distance from horizontal plane and the distance from vertical plane. So you want that point at this much distance from the vertical plane. So you can extend this line, and the point of intersection you can treat it as a triple prime, because in over here, this distance, which is 20 millimeters, is a distance from the horizontal plane, that is this much above the horizontal plane, and this much in front of. So imagine on the profile plane, if you are to look directly into the profile plane like this, okay, so this entire vertical plane would be represented by this line of yours. Okay, so this distance basically is your h2, representing the distance from vertical plane. Does that make sense now?
Yes, sir.
Acha. Now, if you don't want to go by this square method, you could also simply do this, uh, which I believe would be a little straightforward, which is to take this point, let's call it O, as a center, and drawing circular arc, and uh, with the radius of h2, which would ensure that this distance is same as this distance. Okay, is it okay?
Yes, sir.
Yes, sir.
Okay. Acha. Now, let's try this. 6.1b says point B is 20 mm below H, 25 mm behind V. How do you draw that? Earlier it was above and in front. Now it is below and behind. How do you draw that?
Third angle projection.
No, see, if I give you uh, entire problem, so the problem number 6.1 as an assignment, and if you are supposed to draw all of them in the same page, so this is only one possible angle that you can use. So the idea is not to change the angle of drawing. Okay, now this is how it works. So we are talking about a point which is behind the. So let's, for the time being, take an example of a point which is simply behind the vertical plane. Okay, so let's say we have this point P, which is behind the vertical plane. So its horizontal projection, what happens to its horizontal projection? P double prime. Okay, and that would be on the horizontal plane. So this is the projection on the horizontal plane, and that projection, when you rotate the horizontal plane to make it align with the vertical plane, unlike the earlier example, the p double prime point doesn't go below the vertical plane or doesn't go below the xy line. Okay, so this portion of the horizontal plane, what would happen to it? It would actually merge with the vertical plane. So essentially the horizontal projection would appear above uh, the vertical sorry appear above the xy line. Okay, and this is how much, 25 millimeter behind. So so on the horizontal plane, I was supposed to draw it 25 millimeters away from the xy plane, because on the horizontal plane the xy line represents the vertical plane, right? Now you'll have to imagine the horizontal line after being rotated, the negative side of the horizontal line that actually extends into this portion, this region. Okay, so so imagine this is a simple vertical line crossing the xy line or intersecting with the xy line. On that, we would draw p double prime, which is the horizontal projection. That would be over here, which is 25 millimeters away from the xy line. But this one right here is the horizontal projection. Okay, and then the vertical projection, if if it were like this, that on the horizon, it was not below horizontal plane but above horizontal plane, this point p, where it is if it were above horizontal plane. Okay, so the projection p prime, okay, on the vertical plane, that would be somewhere over here, where this distance is 20. Okay, but we are not talking about point P. Here we are supposed to talk about point B, and it is said that the point B. So all I'm trying to say here is, when you are simply plotting points, okay, you can, for the time being, get rid of the idea of first angle or third angle projection. I mean, you see, it's not that uh, the the point is mm, I mean, the vertical projection and the horizontal projection, they are kind of merged on the same plane. Okay, that itself is a possibility. That's all I'm trying to say here. Okay, however, with our example, when b is 20 millimeters below horizontal plane, so so the vertical projection, because it is below horizontal plane, so the vertical projection would lie below the xy line. Okay, so this is now this is now the vertical projection, this one. Okay, so this one is still vp and this one is still hp, but the vertical projection actually lies below xy line, and the horizontal projection actually lies above the horizontal, the xy line. Okay. In order to draw the profile view, um, so here we are talking about a point which would be situated somewhere over here, this point B over here, and so on the vertical plane, this is B prime, and on the horizontal plane, let's say it is B double prime. And now let us talk about its projection on the profile plane, which would be, let's say, B triple prime. So to get that, first off, we would draw a line parallel to xy line from B prime, and for this one, we would again extend the projection, and then we would repeat the process where we would simply rotate this line or draw a quarter circle, and then we would project it back, and then we would have the point of intersection as the B triple prime. Okay. Now, what would be interesting is to look at problem number 6.1D, which says draw the projection of D, which is D is 20 mm below H and 25 mm in front of V. আচ্ছা, এই পার্টটা কি বোঝা গেল? পয়েন্ট বিটা কিভাবে প্লট হবে?
হ্যাঁ স্যার, বুঝতে পেরেছি।
আরো একটা জিনিস বলতে চাই আমি এখানে, সেটা হচ্ছে this is all regarding the change of angle and other thing. So see, here we are simply talking about points, and simply because one point is in certain location, that doesn't change the angle of projection. Because you see, as we discussed earlier, we should be connecting points to draw lines, and then from lines to surfaces, and then from surfaces to volumes. Okay, the thing is, if let's say if I give you the earlier example where you had point A with certain coordinates and then B, and if I ask you to draw a line AB, okay, and ask you to project AB, okay, that would be something. I mean, then you need to question which projection method should you use. See, the projection method doesn't change simply because the point is situated somewhere in the quadrant. Okay. Now let's try to draw this point point D over here. Try to project point D over here. So as we said, 6.1D. D is 20 mm below H and 25 mm in front of V. Okay. Now what we are continuously doing is drawing sketches, and you are encouraged to do sketches, because without doing sketches you would not have the grasp of how the view should look like, or you cannot uh, you know mm, you can make mistakes simply based on the idea. If you try to uh, I mean, mm, if it is below, then it would be above, and so on. If you use those analogies, the chances of doing mistake is higher compared to doing sketches. Okay, think of, there are three different planes: the V plane, the profile plane, and the horizontal plane. And then you have a point which is in front of V but below H. Okay, so this is where planes extend to. Now you have your point D, which is below the horizontal plane but in front of the vertical plane. So this is your point D over here, which is 20 millimeters below the horizontal plane. So this one is your D double prime, and it is in front of the horizontal plane. So this H2 is 25, and this H1 is 20. Okay, so now imagine you have taken all the projections, and now you want to rotate the horizontal plane. So on the vertical plane, how the projection should look like? For that, first let us draw the XY line. This one is a vertical plane, this one is a horizontal plane. Okay, and let us start on a vertical line. But you see, it lies 20 millimeters below, 20 millimeters below the horizontal plane. And I'm drawing the front view first. That means I'm drawing the D prime first. Okay, or the position on the vertical plane first. Okay, so that actually is below. So on the vertical plane, so we are trying to draw the object in on the vertical plane, and this is how the object would look like, or the point would look like on the vertical plane, which would be 20 millimeters below the horizontal plane. So I need you to imagine that whatever this thing is, that thing is actually your vertical plane itself. Okay, right now imagine this is your vertical plane. Okay, and this XY line represents the horizontal plane. And from by looking at it from this side, how would it look like? So imagine this is XY line, and how would the projection look like on the vertical plane? It would look like that the projection would lie below the XY plane by how much? By 20 millimeters. Okay, now let's talk about the horizontal projection. Okay, so the horizontal projection, so once you have projected D on the horizontal plane, and then you have rotated this horizontal plane to come below the vertical plane. Okay, and this distance is 25 millimeters from the XY line. The point D double prime, it is situated at a distance this much, is 25 millimeters. So once you rotate the horizontal plane after taking the projection, this point D double prime comes below D prime. Okay, and that way you have its front view D prime and the top view D double prime. Okay, and if you want to draw the profile view, So start from the, as usual, start from the front view. And this one is for the top view. Now, once you have something from the top view, what do? You revolve it. Okay, on the horizontal axis, and then you draw a vertical line. That way, this distance, that means this much distance, is same as this much, and this, of course, is this one. Okay, and that way you have the projection on the profile plane, D triple prime. Is it clear?
Yes, sir.
Yes, sir.
Okay.
স্যার
Yes.
যদি মানে এই ক্ষেত্রে যদি ওই 45 ডিগ্রি অ্যাঙ্গেলে লাইন টেনে ওইভাবে করতে যাই তাহলে কি হবে সেটা?
হ্যাঁ, একদম হবে। See, basically in the profile plane, think about it. How did the point D would look like in the profile plane? Let's say this is D triple prime. Okay, D point being projected on the profile plane. Okay, you'd look at it below the XY line or whatever. It would be below horizontal plane, right? So this line right here on the profile plane represents the horizontal plane. So it would be below horizontal plane, and this line right here represents the vertical plane. It would be in front of the vertical plane. Okay, exactly the two dimensions that were given to you, below and in front. Okay, and that's what you are getting here in the profile plane. Okay, next problem that we have is problem number 6.2. So that is asking us to draw, let's say, point C with coordinates -12, 17, and -28. Okay, I'm just trying to figure out which one should we take as the x-axis. I mean, vertical is fine, but which one we should take as the x-axis, the other one as the y-axis. And is if there is any guideline. So if we consider this one to be the x direction, this one to be the y direction, and this one to be the z direction, then minus 12 minus 12 would mean 12 millimeters behind the profile plane, 17 would be this much in front of the vertical plane, and minus 28 this much below the horizontal plane. So let's start with these two coordinates, 17 representing this much in front of the vertical plane, and minus 28 representing the 28 below the horizontal plane. Okay, but then how does the first quadrant matter? If I'm not drawing more than 1 points, how does the first quadrant matter? I mean, sorry, the first coordinate matter. Um, Anyways, let's start with the two other coordinates, 17 and 28. So 17 is this much in front of vertical plane. So on the horizontal plane, that would be 17. So this is the horizontal projection, C double prime. And then it says minus 28, which is that much below. So if we only look in these two coordinates, so 17 in front of vertical plane. So it is C double prime. C prime. So this must be 28 and this must be 17. No, no, no. This must be 17 and this must be 28. So now on this one, because once I take horizontal projection, sorry. So yeah, this is the horizontal projection, and the vertical projection C prime would lie 28 millimeters below the line XY. Okay, so this one would be the vertical projection and this one would be the horizontal projection, and accordingly we can also draw the profile view, okay, like the mention that like the method that we discussed earlier. But uh, I can tell you how the first coordinate would be useful. If you use let's say if you use, let's say, another point which is 0, 20, 30. So this much in front of the vertical plane and this much above the horizontal plane. So but then this much in front of your profile plane as well. So what you can do now, if you were to plot these 2 points together, so on this line now you can plot all the projections of the point B, where the distance between these two lines is 12 millimeters. Actually, you can show it using a dimension line. Okay, so it says 20 millimeter in front of the vertical plane. Okay, so B double prime is somewhere over here, the horizontal projection. Okay, so B is somewhere over here. So it is 20 millimeters in front of vertical plane. So B double prime is 20 millimeters away from the XY line, and B prime would be how much further than B sorry, yeah, B prime. So B prime, this distance is this one, this 30 right here, and so the B prime would be shown on the vertical plane 30 millimeters away from the XY line. Acha. So when you are doing in aligned method, okay, so the dimension you are all for dimensioning you are either sorry. Okay, so so the thing is, in aligned method, you are either looking at the drawing from the bottom or from the right, and when you are, let's say, looking at it from the bottom, you write or from the right, you should write the dimension itself above the the dimension line. Okay, it should be above the dimension line. So let's say if this is 30, I'm writing it to be 30. Okay, so these are the two projections of B, and these are the two projections of C. Okay, and probably the first coordinate is only useful for plotting more than one points, showing the gap between the 2 points. Okay, acha. So now, if up to this part is clear, now we would move on to plotting different lines. এই অবধি কি ক্লিয়ার আছে সবার?
হ্যাঁ স্যার।
Yes, sir.
Okay. So let's move on to 6.3. So in 6.3, all lines have length 60 mm. So in the first one, we have a horizontal line. AB is horizontal. (15 mm) over H, 20 mm in front of V. So basically, it's a horizontal line. Something like this, and it is 20 millimeters in front of V. That is these distances are 20 millimeters, and these distances are 15 millimeters over H. Okay, and as you can see, on either plane, it would look like a 60 millimeter horizontal line. Okay, and these are the projection lines. Now, the way you should draw it on the vertical plane is that this dimension right here should be 15. On the horizontal plane, it would be 20. Okay, and if this one is AB on the vertical plane, or A prime B prime, over here it would be A double prime and B double prime. Okay, so this is the top view and this is the front view. And you have already guessed it right, how it would look like in the profile plane. What do you think it would look like in the profile plane?
Sir, like a point.
Like a
There a
point.
point.
Yes, correct. So whenever you are, projecting a straight line, okay, it essentially means that you are projecting two different points which represent the two ends of the straight line. Okay, nothing else. Acha. Let's move on to next example. So the next one is line CD. It says frontal line CD, C having a coordinate this much and inclined 30 degrees upward right. Okay, so you can draw your sketches. So this is the line CD and it is parallel to the vertical plane. Okay, and its coordinates being 0, 20 and 10. So don't worry about the first coordinate. The second one is 20 and 10, which basically means this point C over here is 20 millimeter in front of the vertical plane and 10 millimeters above the horizontal plane. Okay, and in a way, if you draw a line which is parallel to horizontal plane and passing through C, it would make an angle of 30 degree. Okay, so basically it makes an angle of 30 degree with its own projection. So this is a line like that. Okay, so since we know about the point C, let's start with point C. And what we also know that when we look at this line in the front view or normal to the vertical plane, that we see the so-called true length of the line. Okay, and that typically happens when we project a line to a plane which is parallel to it. Now, can you tell me, if I give you a straight line, uh, what is the exact number of planes that are parallel to that line? Is it just a one plane or two planes or more than that? How many planes could there be parallel to a straight line?
Infinite, I think.
Infinite. Yes, correct. So the thing is, if you are confused, imagine this cylinder right here. Okay? And this cylinder has an axis, and you see this entire surface of the cylinder At any point on that surface, draw a tangential plane. And that plane is going to be parallel to that axis right there. Okay, so imagine over here I'm drawing a plane which is tangential to the surface of the cylinder. So that plane is also parallel to this axis right here. So essentially there is one plane which is normal to this axis. Okay, and whatever other plane is normal to that normal plane is going to be parallel. Since there are infinite number of planes which could be normal to a given plane, okay, therefore there are infinite number of planes which are parallel to a given straight line. Okay, for example, um, whether you project uh, a, a vertical line on the xz plane or yz plane, you still get the true length. Okay, now what is the significance of the true length? When you get true length, okay, you also get its true orientation with a plane or true angle of the plane. For example, this straight line right here not only makes an angle of 30 degree with its with a line that is parallel to horizontal plane, it makes an angle of 30 degree with the horizontal plane itself. So what is the true angle that it makes with a given plane can be obtained on the by projecting the line on a plane that gives you true length, or projecting the line on a plane that is parallel to the line itself. So coming back to our line, on the vertical plane, it is 10 millimeters above the horizontal line. So there you go, your dimension of 10 millimeters. Okay. And then you have the point C. Then rest of the things that I'm drawing are construction lines. Okay. Then with an angle of 30 degree, you can draw the line CD of length 60 millimeters. So this one has a length of 60 millimeters and makes an angle of 30 degree. And this is our angular dimensioning. Okay. Now I need to project this line. Okay. Now if you look at it from the top, okay, how would the line look like? It would look like a line that is parallel to vertical plane. Now when you are looking at the top view, or when you are looking at the horizontal plane, or when you are looking at it from the top, uh, you see the vertical plane to be aligned with this xy line of yours. Okay, so this xy line now on your top view represents the vertical plane, and then this would be your vertical projection. Okay, and then you can of course go back to your profile plane. On the profile plane, it would look like a vertical line, the projection. So if you are looking at it from this side, the line would look like a vertical plane. Okay.
Yes, sir.
Okay. So I would stop here. Okay. And your assignment for the day is actually 6-1, 6-2, and 6-3 by Pal Bhattacharya. Okay. And I would take a photograph and I'll upload it to the classroom. Okay. And you then encounter some problems, which is fine, and we will discuss about that, uh, over the classroom or maybe in the next class. Okay.
Yes, sir.
Okay, sir.
ওকে, আজকের ক্লাসে কারো কোনো ডাউট আছে?
স্যার এমনি বলছিলাম যে 21 তারিখের যে দুটো ডিউ ছিল সে দুটো তো দিয়ে দিয়েছি, বাকি দুটো তো 28 তারিখ দেবো না স্যার?
হ্যাঁ, তাই কি?
স্যার ওটা তো মানে ডাইমেনশনাল স্কেলিং আর ওই যেটা ছিল আর কি জানো, সরি স্যার ভুলে গেছি আরেকটা, ওই দুটোই তো বোধ হয়।
দিয়ে দিও, নেক্সট উইক দিও।
ওকে ওকে স্যার।
ওকে। Okay, so I would stop the recording here.